All right, what we are starting this semester out with is just a review of graphing and writing the equations of lines. In the first part of this lesson, we'll just focus on graphing the lines, and then the second part you will focus on writing the equations of lines. So what I would like to start off with is a review of the slope of a line. Remember, this is kind of like the steepness of a line. A positive slope rises up left to right. This is a positive slope. A negative slope falls left to right. A slope of 0 is the type of slope that a horizontal line has. And then an undefined slope is the type of slope that a vertical line has. The formula to find the slope between 2 points is m equals y2 minus y1 over x2 minus x1. That should look very familiar to you. So the first two examples are just finding the slope of the line containing the 2 points given. So for the first example, we will use the first point as x1, y1, and the second point as x2, y2. So we know exactly what to plug in each part of that slope formula. So m equals y2 is 4, minus y1 is negative 2. So this is minus a negative 2, all over x2 is 1, minus x1 is negative 2. Anytime we have minus a negative, we'll make that a plus, make that a plus. So 4 plus 2 is 6, 1 plus 2 is 3. The slope of this line is 2. Go ahead and take a moment in your notes to do example B. The slope that you should have gotten on the second example is negative 1/3. If we use these points as x1, y1 and x2, y2, we can plug in 3 minus 1 over negative 3 minus 3. The next thing that we are going to review is the two different types of equations that we have for lines. We have standard form and what we have slope-intercept form, which is what you're most familiar with. Standard form is ax plus by equals c. Okay? And slope-intercept form, this is our y equals mx plus b. We know that m is the slope, b is our y-intercept. So what we're going to do now is look at a couple examples, just graphing lines. The first one is given in slope-intercept form. The second one is given in standard form. So, with that being said, let's graph the first one. We are going to start off by plotting the y-intercept. That is the place where the line crosses the y-axis. So on the y-axis at 3, we'll plot our y-intercept. Then from there, we'll use the slope of negative 2 over 3. So from the y-intercept, we go down 1, 2 over 1, 2, 3. Go down 1, 2 over 1, 2, 3. And then connect your points for your line. So again, that was first plot the y-intercept, and then secondly use the slope m for more points. In the next example, we are given the equation in standard form, but what it's asking us to do is to rewrite it in slope-intercept form. What that means is we are going to solve for y and then graph. So let's start with our 3x minus 5y equals 15. Our goal is to solve for y. So we will first subtract 3x from both sides. So that gives me negative 5y equals negative 3x plus 15. And then we will divide everything by negative 5 to get y by itself. Negative over a negative is a positive, so that's a positive 3 over 5. 15 over negative 5 is a negative 3. So from there, now again, we can plot our y-intercept. In this case, it's a negative 3 on the y-axis. And then using our slope of 3 over 5, we'll go up 1, 2, 3, over 1, 2, 3, 4, 5 to plot another point. We can do that again, up 1, 2, 3, over 1, 2, 3, 4, 5. Connect your points. On the next two examples, we're given the equation in standard form, and we are asked to find the x and the y-intercepts. So what we are going to do to find the x and the y-intercepts, to find the x-intercept, we think about covering up the y and solve for x. So if we cover up the y, that leaves me with 2x equals 6. The x-intercept is 3. That means along the x-axis, our line crosses at 3. So we can plot that intercept on the x-axis at 3. To find the y-intercept, we'll do the same thing. We will cover up the x. So remember there was a negative 3y there. So negative 3y equals 6. Solve for y, that's negative 2. So that means on the y-axis, the line crosses at negative 2. And then you would just connect those intercepts to draw your line. I would like you to go ahead and try the next one on your own. Same thing. Cover up the y, solve for x. Cover up the x, solve for y. Plot those and draw your line. We should have an x-intercept of 2.5. If you cover up y, 4x equals 10. 10 divided by 4 is 2.5. So on the x-axis, you just kind of guess where 2.5 is. Cover up the x, that gives you 5y equals 10. Solve for y. The y-intercept is 2, and then draw on your line. The last two examples that we are going to look at are graphing vertical and horizontal lines. For this first example, we have y equals negative 3.5. Y equals negative 3.5. This is a horizontal line through negative 3.5 on the y-axis. So we'll plot negative 3.5 on the y-axis, which is about here, and then we'll draw our horizontal line through that. So anytime you have y equals with no x, that's a horizontal line. On the other hand, if you have x equals with no y, this is a vertical line. This is a vertical line through negative 3.5 on the x-axis. So negative 3.5 on the x-axis, and then we'll draw our line through.